Alright kids, how would you guys like to learn limits in calculus?
Yeah.
Alright, so a limit in short terms is as x approaches a number, what does the y value equal? So a good example would be the limit as x approaches 0. So as x approaches 0, it would equal to -2 coming from this side and also coming from this side. So the limit as x approaches 0 equals to -2. Now, another good example is as x approaches -1. So as x is approaching -1, it doesn't equal -1, but it approaches -1. And also from the other way, it also approaches -1. So the limit as x approaches -1 will be -1. Alright, now it gets tricky when you get to x equals to -3 because it's not a constant, or it's not a limit. It would be considered undefined. But even though it's undefined, you can have limits coming from either side. So for instance, coming from the negative side, as x comes to -3, it will make its way for y. Y will make its way to equal -2 eventually. And as they come from the positive direction, y will eventually become 1. So the limit as x approaches -3 from the positive direction equals 1.
Okay, I'm going to talk about discontinuity. There are multiple types of discontinuity, but I'll explain a couple. There is jump discontinuity, which is basically where the point jumps. And then there is
and go. Alright. 1, 2, 1, 2, ready? The tangent line of a curve eluded Newton's round every turn, until finally one day he learned you need a point, a slope, uno, dos, tres. The tangent line of a curve eluded Newton's round every turn, until finally one day he learned you need a point, a slope, a zero. The slope is found from the derivative. The theorem is changed in y equals slope times change of x.
Okay, so today we're going to be learning about the u substitution rule. So first, you're going to let the inner function be your u. and that's usually in parentheses or raised to an exponent. Then you're going to find the derivative of that inner function, which is the derivative of the u function, and solve for dx. Next, you're going to substitute the u and du into the integrand. And usually there's x values right here, and then so you have to change them to u values so that the function will work. Then you integrate, which you take the antiderivative of the function, which goes back to the original function, and then you substitute the function back for u. And they're going to show you examples.
I've got the trig example you said, and you're going to take the sine 3x, and since it's raised to the second power, that's your u. Then when you take the derivative of that, the derivative of sine is cosine, the 3 you bring forward, and so it's 3 cosine 3x. Then don't forget the dx. When you switch it to du, you do du over this as you divide. When you take the integrand, you will do substitute. Sine 3x will be u to the
I'll get
second.
y'all shirts in a minute. I'm kind of
Cosine
counting to make
3x.
sure we have everything, okay?
And then du over cosine 3x, which is right here. Then you'll take it, and obviously these two cancel, and it'll be 1/3 u to the second du. And when you finally work this all out, you'll get sine 3x to the third plus d over 9.
Alright, it's finally my turn. Alright, so I have the integral of e to the 3x plus 1 dx. So the u of the function is the power itself, 3x plus 1. Then the derivative of the 3x plus 1 is 3. And du over 3 is the dx. So you put the e and you put the u in the place of the power times du over 3. The 3 comes out in front to make the 1/3, and then you have the du left, and then you just plug it in. So you have 1/3 e to the 3x plus 1 plus c. Stop filming!
What?